Today we're going to be working on a Panasonic model number TC-P42S30, and a customer sent us the SN board, which is the SC board with the SU and SD board combined into one circuit board. So our SC board and our buffers are going to, when they fail, trigger a 7 or 14 blink code. So I did put the customer's board in the TV, and we are getting a 14 blink code right now at this moment with our test set. So let's go ahead and remove that board back out. We'll do some multimeter checks and see what's going on. So I've removed the board out of circuits, and the components that we're going to be paying specific attention to are the transistors. They are IGBT transistors. They're right here. We have a few over here and here. We're also going to look at the ones over here. Although this one I think is a diode, I'm not sure, but we'll look at all of those for shorts. The most common issue we see is shorted transistors. So taking a look in my beep mode, so when we have a short, we get a beep. We're gonna start over here. And of course we have a beep on this one, both legs. Same with this one. We'll scooch over to these two. This one we have, oh, we do have a short, okay. And this one over here, also a short. All right, so taking a look at the others here, this one's a DG302. This one I have no beep. Let's see, this one is a diode. I'm not gonna check the diode. Well, I will, okay, fine. But typically I've never really seen those diodes go out, so I usually don't. And if I do see them shorted out, typically, because I think they are in parallel, so this one is in parallel with this one in certain areas, the transistor would show a short if this diode was bad. All right, looking at this one, no shorts. And that one's a diode. This one as well. This one as well. And those as well. Okay, here we go. Transistor, no short, okay. And this one also I believe is in parallel with the one I just checked, so it shouldn't, yep, have a short. All right, now let's take a look at this little guy over here. So this one, rarely, but it does sometimes short out. Oh, I think I just made contact with the middle pin, which is normal. It's normal for it to be shorted, but the outside pins, no short. And then we'll go to the other side of the board. All right, and we'll check this one. No short. And lastly, this one. And I think this one is a diode, but let's check it anyways. And also no short. All right, so let's focus back up on the ones that were shorted. All right, so these two, yep, were the shorted ones. One thing that a lot of people will do is they will sell you a repair kit that will include those transistors, but they'll also include the resistors. So the resistors can sometimes burn out, so we'll also want to check those. And this time around, I'm going to go in resistance mode because I want to get an exact measurement. And it says 7R5, which means 7.5 ohms. Let's take a look. And we're getting 56.2. Okay, that's actually good enough. It's close enough to the 7.5. What we want to avoid seeing is it failing open and burning up. And typically when that happens, it'll have a couple hundred ohms or thousands of ohms. And this one also 6.3. So as long as it's within a couple ohms, we're fine. And that's what we're seeing here. And we'll do the same over here with these two. And this one's showing 6.8 ohms. And this one, 5.7, 6.8. Okay, perfect. So that means those resistors are good. We will not need to be removing them. Let's go ahead and remove the 4 transistors that we did find that were shorted. And then we'll recheck the components once they're out of circuit, as well as the board. So I'm going to start off by adding some solder to the 2 smaller legs. All right, and then with my tweezers, while I'm melting the legs, I'm going to lift them up. And it looks like the transistor here The casing broke a little bit. That's okay. Go ahead and do the same over here. And then with my desolder wick, I'm gonna go ahead and remove all the excess solder here. Right, now that the legs are free from the board, we'll go ahead and do the large pads on the other side of the components. And they are attached via a very large ground pad, so they do take a lot of heat. And so with my tweezers on the other side, I'm lifting the components and just waiting for it to become free of the solder. There we go. All right, that's our first one. And that's our second one. All right, we're going back to the beep mode, and we're gonna recheck to make sure that the pads are no longer shorted after removing the transistors. And that one seems to be the case. And same with this one. So let's go ahead and bring back the transistors and check those now. Yep. So the transistors are still shorted, even out of circuit. So that does confirm those two transistors are faulty and will need to be replaced. And what I'm gonna do for these next two is we're just gonna change the technique for removing the transistors, just to show you a couple different ways you can do it. This time we're gonna use hot air. Now I understand I am using the soldering iron right now, yes, but that's just to get some solder on the joints, get some flux on there, and we'll be switching over to the hot air for the actual removal. I do find it that having a little bit of fresh solder both will help me desolder with the hot air, and it'll also be a better indication of when the solder has actually melted visually, because it can be difficult with that old solder to know exactly when it has fully melted and when I can stop putting hot air to the board and components. So I'm going to be looking for that top solder right here to be melting, and that'll be my indication that I can go ahead and remove the components. Oh, there we go. All right, and then we'll do the second one. So the solder did melt, but the component is not. Oh, yes it did. Okay, sorry about that. All right, and I'm gonna remove a little bit of the excess, just like we did last time. All right, so same thing, we're gonna recheck for shorts, not that the components are out of the board or off the board. And no shorts, no shorts, no shorts, no shorts. Okay, now let's recheck the components themselves now that they're out of circuit. Yep, we still get our beep, and this one, beep. And we don't get a beep on this one, but we do get a beep on the left leg here. All right, so that means these are also, of course, needing to be replaced. All right, and then just so that we're all aware for the readings on a component that is good, we should be getting, right now we have OL. Let me check with this pin over here, 0.5 mega ohms. Let's check what this one reads out of circuit, 0.471 mega ohms. And on this pin, open. So the left pin is going to be open and the right pin is going to be about 0.5 mega ohm, give or take. Check this one. Yep, okay, perfect. So if you're unsure of whether or not your component is good, if it's not a dead short, now you know how to compare it, what to compare it to. So before I install my new IGBT transistors, I'm going to do a little cleanup of all that old flux. All right, that's going to be good enough. And we're going to go ahead and start by adding some new solder on the large pad. And then I will be sliding this guy onto that pad. Okay, that's not quite perfect, but it's going to be good enough for now. And the leg is just a little bit longer than where the pad is, but that's okay. It doesn't look like it's going to be shorting out anywhere. Same thing with our second one. Add a little new solder. Sliding this one on. We're going to finish it off with some hot air. And this one, since it is not actually correctly lined up, one way we'll know for sure that it is flowing properly is the transistor will actually shift a little bit and line itself up for us. Oh, and it does not look like that's the case, so I will have to actually give it a little nudge and press it down, make sure it's making good contact. I think that the transistor is a little bit heavier than I thought it was, so it didn't actually adjust itself like we typically see with some of the smaller components. Go ahead and do the same thing to the other one. And same thing, this one's already lined up, so I'm just gonna put some downwards pressure on it to make sure it's really making good contact with the pad. That's gonna be very important with these, because it is using the board as its heatsink. There's no additional heatsink that goes on top of these. There are certain versions and variants of these SC boards that do come with heatsinks on those, but this one does not. We have a little solder that squeezed out over here on the right or left side. We'll clean that up here in a second. All right, so that little ball of solder did fly over. I did need to find it in case it just snuck itself out into a spot that it shouldn't be. So I did remove it, but it is important if you have some solder that splashes where it shouldn't, make sure to take care of that. All right, and then same thing for these two. We'll give it a little bit of a clean before we get started. And I still have a little bit of solder over here, so I'm gonna clean that up first. Just wanna make sure we don't have any solder on these pads, at least not yet. And what I'm gonna do actually on this one is we'll do it a little differently. I realized I probably should have left the solder on those pads. We're gonna line it up using the two smaller pads. All right, and then we'll add a little solder here. And then just as the other two, we're gonna go ahead and finish these with the hot air. And I'm gonna be pressing down with my tweezers to make sure again that there's perfect contact and that the component is nice and flush against the board. All right, there we go. We can see that solder squeezing out. Hang out here for a minute, make sure that it dries up or cools down, sorry. And there it is. Now there's actually a lot that did squeeze out. I could leave it there, it's fine. It's not gonna be a bad thing, but I just wanna clean it up a little bit. So actually we're gonna do a little flux. And just remove a little bit of that excess. Perfect. All right, that looks beautiful. Now let's do the same thing to the other one. Okay, it looks like the legs just melted. And there we go. The large pad just melted as well. Okay, and everything is solidified. Remove that little ball on the side. All right, and I think we're all set. So we'll do a little cleanup and then we'll do our final checks with the multimeter and then put it back in the TV. All right, so back into our beep mode. Let's do our final checks. No shorts, no beeps. Still no shorts, no beeps. Let's check these out. No beep, no beep. Okay, we're all set. So there's one more thing I forgot. And of course I would have noticed when I did the testing, but our grounding screws, the solder is very corroded or oxidized. Whatever this is, it will possibly prevent proper contact between the screw and the grounding pad on the board. Some people theorize that that's actually the reason why the boards fail, is because this happens and then there's not proper ground contact. So very important thing we'll do here is we're gonna actually clean all of that up. We're gonna remove all the old solder, put some fresh solder on there, clean it up so that we have fresh solder, brand new pad for the screw to be making some good contact onto the board. And I'm just using the isopropyl alcohol for the cleanup. And of course a Q-tip. And of course something else we'll do is the backside. So the backside is not nearly as bad. So what I'm gonna do is I'm just gonna add new solder on there. I don't think I need to remove. And now I'm gonna do that 8 more times with the other ones. I just installed the SN board back into the TV, so let's plug it in and see what we get. And there we go, we have some picture. Let me bring the menu up. So we have another successful repair. If you enjoyed the video, leave us a like and subscribe. Thanks for watching.